Okay, so in this video, we're actually going to go through the steps of finding critical value of F and using this theoretical sampling distribution. So you can see on the right, I have the ANOVA summary tables from the two problems we worked on last week, noise and memory, and tanning and happiness. So how we use the theoretical sampling distribution is we have to find the critical values of F. That's the first thing we need to do. And so the critical values of F are available in a chart. Now, I've posted a chart on our Blackboard site in the Unit 5 folder. You can find a chart online, and there's also a chart in the back of your books. So the chart is on page 258 and 259, and I actually copied one page out of it, so I'm going to put it in front of the screen here just so that I can kind of walk you through what this chart looks like. Okay, so this is the first page of the critical values of F chart. All right, now it looks super complicated. It's not. Along the top here, the column labels, this is degrees of freedom between groups, which is degrees of freedom for the numerator of the F ratio. So we're going to be going back to our ANOVA summary table and finding the degrees of freedom for the numerator of the F ratio. For now, and this is going to change moving forward, but for now, what we're doing here, if you remember, the formula for our F ratio is mean square A divided by mean square S over A. Mean square A divided by mean square S over A. What's the numerator, the top or the bottom? The numerator's the top. So we are going to find the degrees of freedom for A, and we're going to find them here. Then, along the side here, this says degrees of freedom within groups, which is degrees of freedom for the denominator of the F ratio. So again, we're going to go back to our F ratio. What's on the denominator? It's S over A. So we are going to find the degrees of freedom for S over A, and we're going to plug them here. So let's assume our numerator was 2, let's assume our degrees of freedom for A was 2, and our degrees of freedom for S over A was 10. We're going to go over to 2 and down to 10, and these are the numbers we're looking at. Now you'll see there are two numbers there. There's a bolded number and a non-bolded number. Well, that's explained on the top of this chart. The bolded numbers are for this 0.05 level of significance. That's just a fancy way of saying the 5% chance of error. All right, so if you're using the chart in the back of the book, the numbers that you're always going to be looking at are the bolded numbers. Now, if you find another chart online, or if you use the one that I posted, just make sure that you read the code at the top and make sure that you're using the 5% level of significance, 5% chance of error chart. All right, so again, I know this is about as clear as mud, but essentially what you're going to be doing is going back to your ANOVA summary table and finding your degrees of freedom. Okay, so my chart has, hang on a second, my diagram has gone away here. Okay. All right, so here we are back at our data. So let's start over here with our noise and memory example. So we're going to our degrees of freedom. Remember, the F ratio is the mean square A divided by the mean square S over A. So the numerator of the F ratio is A. The degrees of freedom are 1. And the denominator of the F ratio is S over A. So the degrees of freedom are 8. So we're going to go back to this chart, and we are going to find degrees of freedom A at 1 and degrees of freedom S over A at 8. So we're going to go over to 1 and down to 8. And you'll see there are two numbers in here. There's 5.32, is that right? Over to 1 and down to 8. Sorry, over to 1 and down to 8. So yes, there are two numbers in here, 5.32 and 11.26. Again, we're going to be using the bolded numbers, So I lost it already, 5.32. So for this problem, our critical F is 5.32. All right, and we are going to label that as critical F. Now our critical F is 5.32. Now here's our observed F, 35.71. Where are we putting that on this chart? Is that to the left of the critical F or to the right? Well, this is a number line. This ranges from 0 to infinity. So 35.71 is greater than 5.32. So our observed F is going to go right here at 35.71. And remember, what does that mean? Well, if our observed F is greater than our critical F, which it is in this case, all right, so our observed F is greater than or equal to our critical F, that means we are going to reject our null hypothesis, which means there is a treatment effect, which means the means are equal. I'm sorry, the means are not equal. Which means noise does affect memory. All right, let's go on to the next example. So what we're going to be doing, and this is for the foreseeable future, all right? So we're talking about the, in this chart, there's bolded numbers, there's non-bolded numbers, there's all these numbers. It's degrees of freedom numerator, degrees of freedom denominator. What does that mean? Okay, for now, anytime we do the one-way ANOVA, which we're going to be working on for a few weeks, for the one-way ANOVA, numerator is degrees of freedom A, and denominator is degrees of freedom S over A. So when you're trying to find the critical F on this chart, you just need to find your degrees of freedom for A and your degrees of freedom for S over A. Now that's going to change a little bit when we get to additional ANOVAs, but for the one-way ANOVA, it's always going to be A and S over A. All right, so for this next problem, we've got 2 and 9. So we're going to go to this chart, we're going to go over to 2 and down to 9. All right, and when I go over to 2 and down to 9, I see there are two numbers there. There's 4.26 and 8.02. Now remember, we're going to use the bolded number. So for this problem, our critical F is 4.26. Now our observed F, which somehow I erased part of this here, our observed F was 29.4. Does our observed F go to the left or the right? 29.4 is greater than 4.26. So 29.4, our observed F goes to the right. So again, this is going to be a reject null hypothesis. So in the training, tanning and happiness one, we are also going to conclude that there is a treatment effect. The means are not equal, and tanning does, in fact, affect happiness. All right, so just a couple more examples to make sure that you guys know how to find critical F. So the drawing of conclusions you're not going to have to do until next week. So I'll do at least one more example on this, but just to make sure that you guys, actually you might have to do conclusions this week. Let's make sure that you guys can find critical Fs on the table. So let's assume our degrees of freedom for A was 1. And degrees of freedom S over A was 12. 1 and 12. What is the critical F? It's 4.75. All right, let's assume degrees of freedom A is 5 and degrees of freedom S over A is 8. What is the critical F? 3.69. Let's assume degrees of freedom A is 8 and degrees of freedom S over A is 16. What is the critical F? 2.59. Let's assume degrees of freedom A is 3 and degrees of freedom S over A is 10. 3 and 10 is 3.71. Okay, now the only other thing that you need to, well, there's probably many other things that you need to know, but one other thing that's very important is what happens if you go to look up the critical value of F and it's not on the chart. All right, so you're gonna start to see that. So the critical values table in our book is page 258, 259, and 260. So for the first, I don't know, 30 or 40 or so, there's a number for any unique combination you would get in here. But once you start to get above 40, there's the degrees of freedom for the denominator. You can't find one for every single one. So there's 40, 42, 44. Once you get to 50, it's 50, 55, 60. Right? So what do you do when it's not on the chart? If it's not on the chart, and here I'm gonna move my computer here. All right, so here we are on the third page. Let's say our degrees of freedom for our denominator was, I don't know, 67, which is not on the chart. So if you look on page 260, you'll see 67 is not on the chart. We've got a 65 and we have a 70. So what do you do when you find one that's not on the chart? You're always going to move up the chart. All right, so if it was 1 and 67, you have to choose between 1 and 70 and 1 and 65. You're always going to move up the chart to the smaller number. So if you have to choose between 65 and 70, you're going to go to 65. All right, let's assume you had to choose between, let's say your degrees of freedom S over A was 5,000. So you had to choose between infinity and 1,000. You're going to move up to 1,000. You always go up the chart. All right, so hopefully that's clear as mud. There will be plenty of time to practice this. We're going to be working on the ANOVAs for weeks and weeks and weeks, so we'll have plenty more time to practice how to do this.